The lapse hypothesis speculates that when people lose situational awareness, they don't lose it in a smooth, continuous way, but it actually is lost in short bursts of complete loss of attention. By analogy, it's often been explained like the difference between a light bulb and a fluoro light bulb dying. For many of you who have seen a fluoro light bulb die, you will know that it doesn't just stop working, or it doesn't get dimmer over time and then just fade out. What happens is it flickers, and the frequency and the duration of that flicker increase over time. What we know from the research literature around this topic is that the way that the human brain loses awareness as it becomes fatigued is very similar to the way that a fluoro light loses its function. That is, the frequency and the duration of off periods increases. If you look at the graph, you will see that attention is either there or not there on that graph. That is, 0 means it's absent and 1 means it's there. And you can see that there are short lapses on the left-hand side of the graph, but the frequency and the duration of those lapses increase until you reach the point on the right of the graph where attention is lost for a significant period of time. This would correspond to sleep onset in the normal individual. But it's important to understand is that cognitive function isn't lost as a smooth, continuous process, but rather as a series of blips in consciousness. In the next section of the talk, we're going to talk and discuss what happens during those blips, or what's sometimes been referred to as brain farts in an individual. But it's important to understand that that loss of function doesn't happen smoothly. It happens in an increasing frequency and duration of loss of attention.